As we start off here in chapter 4, we're going to start out by really just kind of looking into analyzing the graphs of functions. And specifically, we're going to be looking at these terms we want to call the maximum and minimum values, or their absolute and local maxes and mins for a specific function. Okay, and the key, is a nutshell, just kind of sum this up for you guys. Absolute maxes are the very, very high points in all of the domain, and absolute mins are the lowest points out of the whole entire domain. Whereas local maxes are any high points along the way in the domain, and any local minimums are low points anywhere along the domain. So you can have several local maxes and several local mins, but you always have just one absolute max and one absolute min at most. You don't always even have to have them. It's going to be at most one of each. Okay? And I guess the most important thing I can tell you right here is just to kind of focus on the fact that local absolute maxes or mins, so these high points and low points, can only occur at either the endpoints of your domain. So if you took your domain, instead of saying like all real numbers, if you said only from -2 to 3. Okay, so those absolute maxes could potentially happen at those endpoints or interior points where the derivative equals 0 or is undefined. Remember, the only time the derivative equals 0, which is your slope, so if the slope is 0, that's talking about horizontal areas. And if the derivative is, I can't write and talk at the same time. And if the derivative is undefined, then you're really talking about areas where your graph goes like vertical for a moment in time. Okay, that's what we're speaking of there. And to kind of get a little bit more into some theorems and some definitions we want to look at, what this extreme value theorem is basically saying is that if you're looking at any interval where your function is continuous, that's the key. Continuous meaning there's no gaps in it, no jumps in it. So if you're in this continuous interval, then in that closed interval, there has to be an absolute max and there has to be an absolute min. It's like, consider here's a dot right here. We're going to curve and go up to this dot. Okay, because this is a continuous curve, and somewhere in here I've got to have an absolute minimum and an absolute maximum. Right here would be another minimum, but that would be a local minimum. Okay? All right. And then the first derivative theorem for local extreme values. And it pretty much just reiterates the point that the derivative at any point that has been labeled a local max or local min will always equal 0. So those tops of those curves and the bottoms of those curves, kind of like right there, the graph is slightly going horizontal, therefore making the derivative equal to 0. Okay? Now if we talk about critical points are anywhere in the graph where the domain is where the derivative is either equal to 0 or undefined. So critical points must be in the interior of the domain and they cannot be the endpoints. Okay, so the maxes, absolute and local maxes and mins, can be at endpoints or parts of the interior where the derivative doesn't exist or it's 0. Critical points can only occur in the interior of a domain and it cannot be at the endpoints, either where the derivative is 0 or is undefined. So very, very close. The only difference is absolute maxes and mins and local maxes and mins can include the endpoints and critical points can't. Okay, so let's look at example 1. We want to determine from the graphs whether the function has any absolute extreme values in the interval a to b. Okay. Well, to check for any extreme values, remember we look, first of all, we look at the endpoints to see if it's a high point and low point, and specifically we're looking for the absolute, so we're looking for the maximum height and the lowest height. And along that way, it's all continuous. It looks like we have an absolute minimum, I'm just going to abbreviate minimum, at x equals b, so it's happening right here at a low point. It looks like we have a high point up there, so I will say an absolute max at x equals c. A is an endpoint, but that's not a high point or a low point on that curve, so we don't even consider it. Let's go to part B. If we look at this, the potential areas for absolute maxes or mins are either at the endpoints or at higher and low points within your interval. Well, because it's open circle at x equals a, it's an open circle at x equals b, and it's an open circle at x equals c, there's pretty much no absolute, I guess I'll say minima, whether it's maxes or mins. All right, let's go to example number 2. We want to find the absolute extrema for values for, okay, Well, we have the absolute max of 2 at x equals 0, and we have an absolute min, we've got 2 of them, of 0 at x equals both plus and minus 2. Okay. So what's saying is we have low points. The low points down there are right at y equals 0, so it's a low point of 0 at x equals 2 and negative 2, and we have an absolute max of positive 2 up there at x equals 0. Okay, let's go to the next one. Obviously up here is our max, and down here is our min. 3 back here at negative 3 and 2, and over at 2, those are the endpoints, but they're not the highest or the lowest. So we're just going to consider these at down here at negative 1 and up there at, it looks like 2. So our absolute max of the y value there is 2 at x equals 1, and an absolute min of negative 1 at x equals 0. Okay, going on. Let's determine if there are any absolute extreme values for f of x by graphing it. Good idea. Let's graph it. Easiest way is to look at the graph of the function. Okay, so it says we're going to graph the reciprocal function 1 over x only between negative 1 and 0. Okay, so I'm going to get myself some points here. Alright, so let's try. We can equal negative 1, so 1 over negative 1 is negative 1. And then we have to go up to eventually 0. But notice that at 0, if we plug in 0, we're actually going to have a vertical asymptote, so we can't ever equal that. But let's try, how about negative 1/2? So 1 divided by negative 1/2 would be negative 2. 1 divided by negative 1/3 would be negative 3. 1 divided by negative 1/4 is negative 4, and so you're seeing we're going to run all the way down like that. Square root graph. Square root of 0 is 0. Square root of 1 is 1. And square root of 4 is 2. And we're going to do an open circle there because we can't actually equal it. So it's going to curve up to there. Okay. So looking at that, we need the absolute extrema. We need an absolute max or an absolute min. Well, as is, there actually is no absolute min. So if we follow this curve, obviously the left portion is telling us how far down we're going. Because that goes off to infinity, we don't really know how far down it's actually going, so we can't really say anything there. Okay? And then if we come up over to the right, obviously this is taking us higher, higher, and higher, but because it doesn't exist at the endpoint, there's no absolute max either. So right now there are no absolute minima for this graph. Okay, now but let's just make it a little more interesting. Let's play what ifs. If I change that to where we can actually equal 4, so if we could close that dot in, then what we'd still say there's no absolute min, because again we don't know how far down we're going, but would be in this case an absolute max of 2 at x equals 4. Okay, so just by changing that last little endpoint, by including the endpoint, therefore we actually have an absolute maximum exist.